Here's the most embarrassing fact in modern physics, stated as plainly as I can. When you add up everything we can see in the universe, every star, every galaxy, every cloud of gas and speck of dust, you get about 15% of the matter that's actually out there. The other 85% is invisible. It shines no light, it reflects none, it blocks none. We can't see it, touch it, or catch it. We only know it exists because its gravity is holding the visible universe together, and we've been hunting it for over 90 years without laying a finger on it. We call it dark matter, and the honest truth is that the name is a label for our ignorance. So tonight, let's take stock of what we actually know, how we found it, what it can't be, and the uncomfortable possibility that we've been asking the wrong question all along. The story starts in 1933 with Fritz Zwicky, a Swiss astronomer with a famously difficult personality and a famously sharp mind. He was measuring the speeds of galaxies inside the Coma cluster, a swarm of thousands of galaxies moving under each other's gravity. The galaxies were moving far too fast. Add up all the visible mass in the cluster, and its gravity was nowhere near strong enough to hold on to members moving at those speeds. The cluster should have flown apart long ago. Zwicky's estimate suggested there was vastly more mass present than anyone could see, and he gave the missing stuff a name, Dunkelmaterei. Dark matter. Almost nobody took it seriously for 40 years. Then Vera Rubin made it impossible to ignore. In the late 1960s and 70s, working with Kent Ford, she measured how fast stars orbit inside spiral galaxies, starting with Andromeda. Every expectation said the outer stars should crawl, the way Pluto orbits far slower than Mercury, because they sit far from the visible mass at the center. Instead, her rotation curves came out flat. The stars at a galaxy's ragged edge were moving just as fast as the ones near the core, which is flatly impossible unless each galaxy sits inside something enormous and unseen. The picture that emerged is that every spiral galaxy, ours included, is embedded in a vast invisible halo of extra mass, outweighing the stars several times over. Rubin liked to put it simply, what you see in a galaxy is not what's there. And the evidence kept stacking. Massive objects bend passing light, so a heavy cluster of galaxies acts like a lens, smearing the galaxies behind it into arcs. Map the strength of that gravitational lensing, and you can weigh a cluster without seeing its mass, and the weight always comes out several times heavier than everything visible. The pattern of hot and cold spots in the cosmic microwave background, the baby picture of the universe, only makes sense if you include a big helping of invisible matter in the recipe. And in one spectacular case, called the bullet cluster, two clusters of galaxies slammed through each other, the hot gas piled up in the middle of the crash like colliding traffic, and the lensing showed most of the mass had sailed straight through and kept going, as if it simply doesn't collide with anything. Two great heaps of invisible mass, photographed by their gravity alone. For most astronomers, that image settled the argument. So the next question is obvious: what is it? Here, the last half-century has been a magnificent process of elimination. Is it just dim, ordinary stuff, dead stars, rogue planets, lonely black holes? Astronomers ran patient surveys, watching for such objects to drift in front of background stars and briefly magnify them, and the counts came back far too low. Ordinary hidden objects can't come close to covering the deficit. Could it be neutrinos, the ghostly particles that already flood the universe? They're real, but they're far too light and far too fast. A universe whose missing mass was neutrinos would have smeared itself out, growing galaxies in the wrong order. Ruled out decades ago. Whatever this is, it appears to be something genuinely new, matter that carries weight but ignores light entirely. Physics has a favorite suspect, and we've spent fortunes trying to arrest it. The idea is a WIMP, a weakly interacting massive particle, a heavy relic from the Big Bang that barely touches normal matter. If the galaxy's halo is made of them, billions stream through your body every second, and very, very rarely one should clip an atomic nucleus. So we built traps, tanks of liquid xenon buried deep underground to shield out everything else, watched by detectors that can register a single flash of light. The biggest, LUX-ZEPLIN, sits a mile down in a former gold mine in South Dakota, 7 tons of xenon in the quietest place on Earth. Its latest results, from more than 400 days of watching, are the most sensitive dark matter search ever run. It has seen nothing. Every such experiment for 30 years has seen nothing. Each null result tightens the net, and the suspect keeps slipping through it. Which is why a heresy that's been waiting in the wings since the 1980s keeps getting louder. What if nothing is missing? What if, instead, gravity itself works differently in the faint outskirts of galaxies than it does in our solar system? That idea, modified gravity, or MOND, does something genuinely eerie. With one tuned number, it predicts the rotation curves of galaxy after galaxy, no invisible halo required. Some of its advocates argue we misnamed the problem itself, that we discovered dark gravity and called it dark matter. But the heresy has its own crisis. Point modified gravity at clusters of galaxies, and it comes up short by roughly a factor of 10. Even with the new rules, clusters still need heaps of unseen mass. And it struggles badly with the bullet cluster, and with that infinite universe pattern in the microwave background. So the mainstream holds, for now, most cosmologists still bet on a particle. But the fact that the debate is alive, 90 years in, tells you how little of this is actually settled. Step back and the situation is genuinely strange. We have mapped dark matter across the sky by its lensing. We've weighed it, budgeted it, and built it into our standard model of the cosmos, where it forms the invisible scaffolding, a web of dark filaments, along which the galaxies grew like dew on a spiderweb. Our own galaxy is thought to sit inside a halo of it, 1,000,000 light-years wide. By every gravitational measure, it's the most common substance in the universe. And we have never detected a single particle of it. Not one ever, anywhere. So what is dark matter, really? After 90 years, the honest answer is a choice between two revolutions. Either the universe is mostly made of a kind of matter physics has never touched, waiting in some tank or collider to finally announce itself. Or our law of gravity, the oldest law in science, quietly fails at the edges of galaxies, and the revolution is in the rules themselves. One of those two things appears to be true, and either one rewrites the textbooks. The universe is keeping, for now, its largest secret exactly where it's kept it all along. In the dark.